Instrumentation Amplifier. This is one of the operation amplifier, and this is used to find out it amplifies small differences in the input signal, and it's also used for thermocouples, acquisition systems, etc. And here's the circuit. Here we have V input and then V output. Okay, let's call this one as V2. V input, V output, and you can see that these two operation op-amp the combination of this one gives the input and input for the third operation amplifier. The first output of the operation amplifier of this one gives the input of this, and the second output of the operation amplifier here gives the input of this, and here we have an output. Okay, now based on that we have an expression for this V output that is given by R2 over R1 times 1 plus 2 R3 over R1 times V2 minus V1. In this video we are going to see how to derive this equation. To derive this equation, I'm going to just copy this diagram and bring it to next page because I don't have enough room to do here. So I copy this one and put it over here, and I'm gonna erase this part over here. Okay, now let's go ahead and continue. So first what I'm gonna do is I'm gonna write the V output expression for the first amplifier, that is V1 output, and that is equivalent to here if you see we have R3 resistance, R4, and R3 is the feedback resistance, so that one will be coming on top, and this is 1 plus R3 over R4, and whatever the V input is, in this case the V input is V1. Okay, that is for the first op-amp. And for the second one, similar, V2 sigma, and here again the feedback resistance is R3, and then here we have one parallel to it, that's R4. So this is going to be 1 plus R3 R4, and the input voltage here is V2. Okay, and if you look at the third one has a input of V1 output as the first input and V2 output as the second input, and we have this resistance over here. Now to express this one, first we had to know this equation, like we can assume the current through this is I, so we can also write the equation in terms of current in Ohm's law, that is given by V over R, and then so let's say the current flowing, we are looking at the current through this is, let's consider this as I. If you consider this as I, then voltage differences divided by the resistor in between gives the current. So if I look at the voltage differences from V1 output to V2 output, that is V1 sigma minus V2 sigma divided by the resistor in between, that is R4, and then all of them are connected in series, so we just have to add them to it. So here R3, and then we have another R3, so all together it's 2 R3. Okay, that is also equivalent to, if we here we have VA, VB, another voltage, and if you consider that voltage also, it's going to be the same thing. If we consider VA minus VB and the resistor in between, that is R4, it is equivalent to this as well. So we can equate these two equations. And also another thing, that in op-amp, you know that the voltage in the positive terminal and the negative terminal will be equal. Okay, and since we don't have any resistance between, and here we have VB, we don't have any resistance between, so there's no voltage drop. So whatever the V2 is going to be the VB, whatever the V1 is going to be the VA, whatever the V1 is going to be the VA. There's no voltage drop. So this, instead of VA minus VB, we can also rewrite this one as V1. A is at 1, so V1 for that, and VB can be replaced with V2 divided by the resistance between, that's R4. Okay, so we can express that one like this. And what we can do is we can equate this and this also, because both of them are equal to I current. So V1 minus V2 divided by R4 is equivalent to V1 output minus V2 output divided by R4 plus 2R3. Okay, now if we rearrange this one in terms of V1 output minus V2 output, let's continue in the next page. If I rearrange this equation in terms of V1 output minus V2 output, that is equivalent to V1 minus V2 divided by R4 multiplied by R4 times 2R3, R4 plus 2R3. Okay, so this is what we have so far. Okay, so we have V1 minus V2, R4 plus 2R3. Okay, and we can do one more thing. Okay, V1 minus V2 over R4. Okay, we can also write this one as V1 minus V2 times R4 plus 2R3 divided by R4. I'll just move this one to here because this is like 1 over R4 times this, so it is equivalent to R4 plus 2R3 over R4 as well. Okay, so if we do that, then it's going to allow us to simplify this one furthermore by we have R4 here, so we can separate this one like R4 over R4, then 2R3 over R4. So if you do that, that's going to be V1 minus V2. If you separate R4 over R4, that's going to be just 1, and then 2R3 divided by R4 remains the same. Okay, so this is it. That is V1 output minus V2 output. Now if we write the equation for the V output, that is over here, this is what we are interested in. We are trying to derive this one. So this is for the V output equation. So V output has first input, that's V1 ohm resistor, and V1 ohm voltage output from the first one, that's the input for this amplifier, and V2 output from the second amplifier here is the input for this one, positive terminal. So the equation for the V output here is going to be the voltage difference. Okay, that is V2 output minus V1 output, and the feedback resistance over input resistance. So here the feedback resistance is R2, and then divided by R. Okay, I forgot to, yeah, there should be a resistance here, R1, Okay, so this is like feedback resistance over input resistance. Feedback resistance R2 for both of them, and then input resistance R1. So the equation we are going to have is R2 over R1 times the voltage difference, that is V2 ohm, V2 sigma minus V1 sigma. Okay, now if you look at this one here, we have here what we derived is V1 sigma minus V2 sigma, but what we have here is V2 sigma minus V1 sigma. So what we have to just flip this sign right here, like if we write this one in terms of if we write this one instead of V1 minus V2, we can write this one as V2 minus V1. If we do that, this is going to be it's equivalent to flipping. So if you do that, then this is going to be R2 over R1 times V2 minus V1 times 1 plus 2R3 over R4. And if you look at this one, R2 over R1, 1 plus 2R3 over R1, and yeah, this one should be R4 here. Yeah, 1 plus 2R3 over R4, V2 minus V1. This is the equation for the V output, and we show how to derive this one. Okay, so and also like if we can also make the R2 and R1 equal. If R2 is equal to R1, then we can get rid of this part over here. Then finally we will end up with V output that is equivalent to V2 minus V1 times 1 plus 2R3 over R4 okay, and V output could generally given as the gain times V2 minus V1, and here the gain is this. In this equation, the gain is A is equal to 1 plus 2R3 over R4. Okay, and that's basically it. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.